Welcome to a lesson on engineering notation. So engineering notation is very much like scientific notation, except that it is much more cool. Just how cool is engineering notation, you may be wondering? It is actually Doc from Back to the Future level cool. And so with that, we've got our friend Doc coming at us with our first example of engineering notation for us today.
It's electrical, and I need a nuclear reaction to generate the 1.21 gigawatts of electricity.
1.21 gigawatts! 1.21 gigawatts! Great Scott! What the hell is a gigawatt?
All right, and as you can see from the video clip there, and this is a good spot to stop and remember that just like with the video clip I just showed, you can go back and re-watch and rewind this video as many times as you need to learn a topic or get help from the video. And you can also reach out to the Schlegel helpline through our Remind class, or at this point you should have my personal cell phone number. Feel free to get a hold of me anytime, and I will be glad to help, in addition to the videos always being available to you. So, with that, our objectives for today, you may have noticed that Doc is needing 1.21 gigawatts, and this doesn't seem to make sense to Marty. Marty seems a little bit baffled, and at the end of the clip there, he runs out of the garage yelling, "What the heck is a gigawatt?" And he uses a little bit more colorful language than that, but you can feel free to go watch the video clip again if you'd like to see that. And so objective number one for us today is to know more than Marty. At the end of today's lesson, students will be able to understand and use what we call SI prefixes, like gigawatt, to represent numbers written in engineering notation. And so we'll be naming some numbers and that sort of thing. Objective number two is going to be that students will be able to understand the similarities and differences between scientific notation and engineering notation. Objective number three is that students will be able to convert numbers from standard form to engineering notation form, which in some circles is also called technical notation. And objective number four is students will be able to use engineering notation and SI prefixes to represent very large or very small numbers in the context of electrical or electric values such as voltage, current, and resistance. Now, it's important to understand that there is a lot of pretty high-level vocabulary here, and it's not important to know all of this vocabulary right away. We are going to spend some time learning it, and I just wanted to make those SI prefixes match in colors so that the words jump out there. But we've got basically three different sets of vocabulary here. Scientific notation, which you should have some experience with, engineering notation, which we will go over today, and SI prefixes, which we will also be going over today. And so, essential prior knowledge for today's lesson, you should have already had a lesson on scientific notation prior to this, but in case you missed it, or if you need a little bit of a refresher, I have included a video link here for you to get a refresher on scientific notation so you can be prepared for today's lesson if that's something that you need. And with that, we are going to be back in another video with some notes and examples from Schlegel.